Hello and welcome back. This will be a focus lesson on identifying discrete and continuous functions. There is a PDF available if you'd like to print it out and follow along. Let's talk about a discrete function. It's any function that contains isolated points. They're sometimes referred to as graphs, or a function or graph that contains isolated points, sometimes referred to as gaps in the graph. As you can see, this particular graph appears to have these gaps in it. Discrete data generally does not contain fractional or decimal values for both domain and range. It could contain them for one, but it wouldn't make sense to have fractional or decimal values for the other. We'll give a few examples of those here in a minute. Continuous function that is unbroken. So when graphed, you see a solid line. In general, continuous data can contain fractional or decimal values for both domain and range. Look at the equation. Y is equal to 2x minus 1. Which is discrete or continuous? What is the range of each? Well, on the left-hand side, they give us a domain value of just 0, 1, 2, and 3. And in order to graph those points, we're going to substitute these numbers in place of x, and each time we do that, we get a point on the graph. And we're not allowed to use any other domain than the one that they gave us. And that's how we end up with these gaps between the points. So this on the left then would be a discrete graph. On the right hand side, they're telling us to use all x's greater than or equal to 0 as our domain. So we have a starting point like we did on the other one, but we're including all possible values for x in between, so not just 1 or 2 or 3, but 0.1, 0.2, 0.3, and anything in between, which makes it infinite, which is what creates that straight line or solid unbroken line. Now they did ask us what is the range. Well, the range value, we have a domain, which is our x, and then we have a range value, which is our y. So basically, we just need to find the output values for each of our, or the y values for each of our points. So this first point right here, we have a range of, let's go ahead and put r equals -1. For this one right here, our y value is +1. For this one right here, our y value is +3. And this one right here, our y value is +5. So that would be the range of this one. Now over here on the right hand side, our range begins at -1, but it goes infinitely upwards because our x's are going infinitely to the right. So this line should go up into the right infinitely. So our range values are going to be all numbers greater than or equal to -1. So we have to express that one using an inequality rather than making what's known as sort of a roster notation or roster set of our range on the discrete function. So the right hand side is a continuous function, the left hand side is a discrete function. Couple of tables here, and we're going to ask if it's discrete or continuous. We just really have to kind of interpret what the data is telling us. So if we look at the first graph, we have the duration of storm, which is x measured in hours, and the amount of inches, which is our y value. Now we know that storms don't last only 1 hour or 2 hours or 3 hours. They could last any number of hours in between. Same thing with the amount of rain. We don't have to measure them in 1 inch, 2 inch, 3 inches. We can measure them in any amount of inches in between, since both of those can contain decimal or fractional values. And if we were to graph them on a graph or on an XY coordinate system, we would see a solid line. That would make them continuous. The second one down, the number of DVD rentals, which is x, and the cost of those rentals, output, which is y, range values. And even though dollars in this bottom half here can actually be measured in fractional values, it doesn't make sense to say that we've rented 1.5 or 1.25 or 2.6 videos. So this top number can only be measured discretely. So if I were to put that on a graph to show how many DVDs I've rented and their costs, I would have gaps in the graph itself. So that would be a discrete function or a discrete relationship. Next one down, hours since 12 p.m. and distance driven. Well, we can measure more than just 2 hours, 4 hours, 6 hours. We can measure 2.5 hours, 2.25, 2.75 hours. So we can measure fractional values for the first one. And we don't know how fast we're going. And if we're going to measure a fractional hour, then we can have probably a fractional mile as well. So I could have a fractional number here. Since I could have fractional numbers in both, we should have a solid line if we were to actually graph all the hours or all the miles driven since 12 o'clock noon. So that would be a continuous graph again. Last one, volume of water, which is X in cubic inches in the approximate weight. Well, I can measure water with any amount of volume, not just in whole integer values like 3, 6, 9, and 12. So I can do fractional values. And of course, the weight of it would vary directly with the fractional value of volume I'm measuring. So I would have another continuous graph.